Polygons are proportional. So if you can solve a proportion statement, you can solve many of these problems. If AB divided by 8 is equal to 3 divided by 2, I can solve this as an equation by multiplying both sides. That leaves me with 3 divided by 2 times 8, which is the same as 1.5 times 8, which gives me an answer of 12. To check if these rectangles are similar, you can look at corresponding sides, but it's actually easier to just divide out the lengths and the widths of each of these rectangles. For ABCD, if I divide the length and the width, I get 2.84. For EFGH, I get 7.5 divided by 2.5, which is 3. And for IJKM, when I divide them, I get 3. Because both of these are the same, it means these two are similar rectangles. So EFGH is similar to IJKM. Are these pentagons similar? Well, if you look at them, clearly they're not the same. They're not scale copies. For two polygons to be similar, they need angles to be equal and corresponding sides to be proportional. Even though the sides are twice as long on pentagon B, you can still see that the angles are nowhere near equal. So I know for sure that these two polygons are not similar. To find the lengths of the missing sides, I can use a scale method. For this first set of triangles, I know that if I take 8 times 8, I get the other side 64, which means if I take the missing side x times 8, I should get 88. So now I have to think, what number times 8 will give me 88? Well, that number has to be 11. So x is equal to 11. For the other pair, I can set up a proportion if I want. So x divided by 8 is equal to 30 divided by 6, the corresponding sides. By solving this, like in our first question, I can get that 30 divided by 6 times 8 is 40. To solve these, I'll set up some proportions. Pn and its corresponding side ut, which is 1.6, is equal to qp, which is 3, and vu, which is 2.4. By dividing and then multiplying, I can solve this, and I find that Pn is equal to 2 centimeters. The proportion for Ts, I have its corresponding side Nm, which is 3.5, and I need to be careful to set my proportion up correctly. I'm going to use 2.4 first, divided by 3, and from here, if I divide and then multiply, I should get 2.8. Use similar triangles to find the height of the tree. So I need to find the height, which will be the height here. If I set up the proportion, I use the height of the person, which is 1.5, is equal to the distance from the mirror, which is 6, divided by 1.7. Multiplying both sides by 1.5, I get 6 divided by 1.7 times 1.5, which is 5.29 meters. So the height of the tree is 5.29. I need to find the length of the lake. Luckily, I can use two similar triangles to figure it out. If you can't see the two triangles, sometimes it's better to break it up. I have the small triangle, which is 40 and 30, and the bigger triangle, which has 140 meters by, well, the unknown. I set up the proportion again. The length and its corresponding side, 30, is equal to 140 divided by 40. I solve this by dividing and then multiplying. When I calculate this, I find that the length of the lake is 105 meters.